Hello everyone, thanks for coming along to my talk. Yeah, they accidentally let a dev into an InfoSec conference, so you're about to get a talk from a dev on InfoSec. So who am I? Developer by background, head of secure coding at the Bureau of Meteorology. So what does that role mean? Well, it's a bit of, I'm going to call it a somewhat experimental role. It's focused on fairly obviously making sure that the development process has more secure outcomes. That's not necessarily a role that every organisation has. It might be something that just a general senior manager or a team manager has, or is managed through feedback from a security group. So it's a little bit of its own experiment in whether or not we can make improvements to the way we build our internal software. We've certainly got a fairly large in-house build at the Bureau. So unlike some places which might be more focused on, say, procurement-based activities to obtain their software, we've got a fairly large in-house build, which also means that the feedback loop between finding an issue and correcting it can be fairly tight. We don't necessarily need to negotiate with a vendor around obtaining a new release of a piece of software. It's something we can do or could do through a continuous integration / continuous deployment model if we have all of the right feedback loops in place. It's also, as our agency, so I've said we've got a significant dev capability. We also have a lot of science. So we have many scientists in our organisation. Basically what a scientist does all day long is sit in front of a computer, type, and computer code comes out, but they're very clear that they're scientists, not developers. Yet, nonetheless, something we still have to give some due care and attention to the security of that activity. And then we're also an operational agency. So when we're talking about our company's risks, they're definitely not just IT risks. The risk profile of the Bureau, we've got some fairly significant public-facing services. So when we're lining up our cybersecurity risk as an organisation, they're lined up against services which can, in some cases, go all the way through to loss of life and fairly substantial economic impacts. So our risk management frameworks have to encompass both the business risks in a fairly significant way as well as cybersecurity risks. I'm trying not to make assumptions about the pre-existing knowledge of the audience. It was really hard for me to work out how to give a tightly focused presentation that made sense and yet was going to appeal to a tolerably fairly general audience as well. So I might just do a quick round the room just so that the audience itself can get an understanding of who else is here. Not going to take too long, just really quick. So who's been a software developer before? Hands up. Great, okay. All right, it's my team that showed up. That's cool. Who has not been a software developer and has been in an ops environment? Okay, maybe a third. And who's actively involved in say, pen testing or red teaming or something like that? Smaller amount. Okay, so that'll help me work out how to pitch my slides. So this is what I thought about who the audience was going to be. So everyone's security interested. I'm security interested, motivated enough to get to a conference, so I can assume a certain amount of pre-existing knowledge. Broad variety of roles. I think there might be fewer managers than I'd imagined, probably slightly higher up on the hands-on security professionals, and frankly more devs than I'd expected as well, because when I was looking at what AUSCERT was, everything's backwards to my way of thinking. Everything is incident backwards, and everything I do is build forwards. So we've got to work out how to stitch up incident backwards with build forwards, and that's a lot of what I'm trying to talk about today. So who do I want to reach? Anyone who just needs a starter on securing their build pipeline. I don't really mean the infrastructure hardening of your build pipeline. That's also important, but I feel like that's very much just that's the job of a traditional infrastructure team. I'm talking about the output code that a development process produces and the hardening and security of that code that is produced, as well as the systems. If we happen to have any product vendors in the room looking for bright new ideas, I've got a few things that I'd love if you'd build for me. People who want to be part of a secure dev community. There's really good dev communities. There's really good InfoSec communities. Secure dev is still a little formative, I think. And anyone who wants to directly contribute to improved scanning tools. Some of the ideas might be a bit old hat. I was quite worried that talking about secure CI, sec DevOps, some of the concepts, how we could take it further, might be a bit old hat for this audience. So I went searching for something to appease my concerns. I found this 5 hours ago, coming out of one of the latest reports from Black Duck. So apparently it can take 6 years to steer a disclosure of an open source vulnerability in a commercial product through the pipeline. So, okay, maybe it's not, maybe it's still a problem. And how much open source is actually in our products? Again, coming from the same report, like fair bit, 30 to 70%. A fair chunk of our commercial products are open source code. So, okay, I feel like I'm a little more comfortable and a little more at home now. I'm also really just talking, I'm well aware this is only one piece of a puzzle. Something I really don't want to do is say, somehow we've thought of the answer to all the problems. It's just securing your dev life cycle is really just one piece of the puzzle. Okay, a few things we're not talking about: decommissioning, organisational decisions, architecture, deliberately insecure configurations, things like that, not really focusing on that. Not really focusing on language choice and language support. I've got opinions about them, but this talk doesn't pertain to those. Or operating system level patch management. That's also a thing, but I'm really here talking about product level or application level vulnerability management. Okay, so pieces of the build puzzle. So if you imagine you turn up in a new company, you've got a new job, say everything's new. Certain things you're going to find, you just kind of inherit. You show up, there's a culture that's in place, there's a level of maturity and knowledge, there's existing products with existing libraries and dependencies, an existing attitude towards quality during development, and the code base that happens to be there. And if you show up as a new manager or move into a new role, you're going to inherit a lot of things. So we're going to have to deal with that. Certain things will just kind of happen. Business as usual, part of the day job. With any luck, continuous integration is part of the day job. Code reviews should be part of the day job. Linters, checkers, static analysis, unit testing, security-oriented unit testing, some security automated analysis. Those things aren't but should be pretty much expected, but you'll still find a pretty wide variety of whether or not this is in place within existing teams. If I look at some of my previous experiences in various teams, definitely some of them have been a lot more security aware than others, and I really discovered a lot of the security objectives when I moved to a more security aware team, and it was quite an eye-opener for me. I'd never got paid particularly to do it. I'm not saying people don't care about security, but as a team that is focused on functionality, there are a lot of concepts that just might not be a priority for your group. And when we're thinking about supply chains, your organisation might be selling a security-oriented product, you might be in a security-oriented area, you might be selling to security-aware customers, but it's not going to be true for all of your upstreams. If you go back to that ratio of code coming in from open source, again, no criticism on open source, but not every single one of those people is going to be working in a security-aware team. So even though describing best practice and defining it might be a little old hat, achieving it isn't. Quality really never goes out of style. Then we have what I call discrete activities. So these are things like fuzzing, dynamic analysis, pen testing, dealing with code rot and patching, if it's not already part of the day job. They'll come up. They'll be organised at the end of a project or as part of a gate or because something happened. So they'll be more of a discrete activity. And in many cases, I'd say penetration testing falls into that discrete activity category. It might be organised by an ops team or a security team around a piece of infrastructure rather than an app. And it may or may not be that every app or every library or every piece of your supply chain is necessarily going to get hit by that if it's not part of your standard build pipeline. So what does all of that mean for InfoSec? So, I mean, broadly, we're all talking about cost and risk. I'm not going to spend very long on cost and risk because I realise it's fairly dull, but it's nonetheless true. So when someone brings in a penetration testing team, they want to bring in the attacker mindset and the attacker behaviours so that they can validate that what they've done is okay. Some people will think it is the actual assurance. So if you brought, I've heard it described, if you get 5 painters and you say, paint me a blue dog, you get 5 blue dogs. They'll all be completely different. The same thing is true of a pen testing exercise. There are certain commonalities, but it's a creative process. And because it's a creative process, people may well find different paths to finding vulnerabilities and achieving their objectives. As a result, I've always seen penetration testing far more as a validation exercise than as the actual assurance exercise. It's can provide you, if you have an infinite number of penetration testers, you know, a team of 100 of them just sitting there penetration testing after every commit, fine, then it's your assurance. If you have it doing, shall we say, a random sampling of your work, it's validation, it's not actual assurance. So what are we talking about? So cost. Cost of penetration testing in that kind of comprehensive way I've just described is unrealistic. Cost of development is generally you're going to have more developers than pen testers, so you have an uneven distribution. If you've got new code versus validated code, the best you can achieve is a sampling of the code that you've produced as a rule, or your infrastructure. Yes, it'll tell you how vulnerable you are to the most, depending on how much you pay for your pen tester, somewhere between the most obvious and the medium obvious and the very significant issues that you're still vulnerable to. But how effective is that cost, and how does it relate to the costs and benefits that a genuine attacker is going to be facing? So back in a past life, I did a whole bunch of economics, which I enjoyed because it provided me a lot of conceptual models. So what we're really balancing is the value of our system operations up against the value of a campaign to an attacker, and the cost of our development versus the cost of their exploit development. They're the kind of analogous components. And what we're trying to do is increase how much we're able to produce, but in terms of the security outcomes, lower our security costs so that it's cheaper for us to find, fix and secure our systems than it is for someone else to develop an exploit against them, whether that's at the product level or the infrastructure level. One of the other things I want to highlight is something called opportunity cost. So that's this thing down in the bottom right there called loss if discovered. So that means, you know, you've lost your 0 day. Someone's found a bug, they've got in, you find it and you fix it quickly, you radically reduce the value to the attacker of that exploit. So if you can tighten up your product life cycle, you can reduce the value to an attacker of that exploit. That may be cold comfort if you've already been exploited, but if you can establish your reputation as a group, team or product that is on the money when it comes to finding and fixing these things, both in terms of your CVE response but also in terms of benchmarking your software quality, people are going to go to the next guy. Okay, they're going to look to the next person. So very quick review of supply and demand. This is another way of thinking about the same thing. So in this particular diagram, it's a very basic supply-demand diagram. Don't get too focused on, this is a conceptual model, don't get too focused on the precise meanings here. But what I've got here is, so demand here is the demand for exploited systems. Now that, you might think of that as from an attacker perspective. How valuable are they? How much effort are people putting into it? And how many of them are you producing as a software organisation? Everyone is to some degree vulnerable. I think that it is entirely reasonable to talk as a group of adults about the fact that, well, when you read the papers and you look out there, it is a matter of risk, not of certainty. So the more systems we produce, you know, with a particular vulnerability rate, you know, sort of level, well, we're increasing the potential supply of vulnerable systems. People are, as far as I can tell, putting more effort and paying more money into exploiting these systems. People are also putting more money and more effort into securing these systems. And the interesting thing about InfoSec is you win on both parts of that demand and supply curve in terms of whether your skills are in demand. So it's a very comfy place to be from a career perspective. So our objective really is to reduce the supply of, from a developer perspective, reduce that supply of vulnerable systems. And to me that means we've really got to reduce the cost, because this is cost and risk are natural bedfellows. Okay, so that's my basic pitch. How do we do it? Shift left. Okay, I'm going to try to get through. I promised a few things in my abstract. If you're like me, I'm not really sure you're sitting there remembering my full abstract. I promised a few things. I promised some new thinking. I haven't really given you any yet. I've given you a kind of exposition of what I consider best practice. I promised you some machine learning. That'll come right at the end in just a little quick sort of, you know, smoke and mirrors show right at the end. And I promised you a new way of looking at these. So as an operational agency that produces its own code, I'm less focused on our products than I am as on our holistic code base. I'm more focused on what is our fleet of application developers doing, and how's our central or multiple, how's our overall portfolio of code base going. I'm less worried about whether you know, just Microsoft Word is a good product if I'm selling Microsoft Word, or just, just a particular product is a good... I'm not trying to secure products, I'm trying to secure an organisation, and I'm trying to improve the outcomes of it. So if you're in an organisation with a dev function, can you answer for yourself, does anybody know what the indicators of quality are for your organisation as a whole? And if you can't, the answer is why we have a head of secure coding role. So I'm focused on looking at where are all those scripts that are lying about the place checked into some GitHub repo, some Git repo locally somewhere. Where are all of your 20 teams? You know, how are they all doing? You know, forget about that product that we've done all the penetration testing and the hardening and put all the best devs on and put all the leads on and put all the effort on. And what about those, 200 lines of PHP someone wrote 5 years ago that's still hanging around somewhere inside the network onion? So, a few basic assumptions here. The later something is done, typically the more expensive it is to fix. I realise that taken to the extreme, that makes for one heck of a first day on a new project. Something always has to come later, right? But with security, particularly with security automation, it's possible to roll in all of the positive feedback loops on day one of development at essentially not a significant cost. If you try to run that, either if you've never run those tools as part of a development process, like super waterfall, no standardization on tools, for example, and it all comes out in the pen testing report at the end, you're going to have a devil of a job cleaning all of that stuff up. There is a large category of problems that you can just totally avoid by turning this stuff on right at the beginning in terms of secure CI. So if anyone's not doing it, it can be hard to achieve with teams, and there's cultural change, and you've got to pick products, and you've got to work out if, there's difficulty to it. But it's the right answer as far as I'm concerned. The more something can be picked up automatically, fewer mistakes will pass through. Software development is a refinery process. Tools matter. Tools drive culture as well as learning and efficiency. So yes, it's easy to look at these tools, and we will a bit later, and go, oh my goodness, look at all of those things they didn't pick up. But the feedback loop they provide is invaluable. So if you can provide there's both the technical coverage, but then there's the cultural value of having every developer have this feedback loop sitting in front of them as part of their dev lifecycle. So CI tools drive culture. Humans and computers have different failure modes. Computers are really good at not getting bored. They will comfortably check all of your code every commit. No problem. Not an issue for a computer. Humans will get bored. Okay, they're more creative. They can change strategy. They can formulate a more complex. They can work out how issues would relate to each other to form a more complex exploit. But they get bored. Okay, computers don't get bored. Licensing. Again, I don't know if any vendors are in the room, but freemium is really the preferred licensing model. If we think about not just the take everything I just said about organisations and just go, well, let's just talk about the whole community, me, the people I bought software from, the people I'm giving them to, someone building some products off my services, the dozen odd open source things that might be in this thing. You go, all of them. If we can get the basic tools consistent and freely available, even if the more advanced capabilities that come from a commercial vendor are pay to add, if we can uplift the entirety, that's probably secured us more than more than just securing ourselves. We don't want to build... Well, it's great to live in a fortress if you can afford a fortress. We don't want to live in a world of fortresses with bandits roaming the highways. We want to try to do our best to provide ease of adoption to security uplift to our development supply chain. Okay, so let's talk a little bit now. So the new thinking in that is the organisational holistic approach in terms of managing all code as opposed to a product-oriented view. Let's talk a little bit about the technical side now. So the actual weaknesses that lead to these CVEs. So when I started, CVEs were kind of a mystery to me. They were these amazing things that were the gold stars of being a pen tester, okay? And, I'm like, wow, these people can just they can decompile a thing and they can read assembly and find it and, get in there, and they've really, that's an amazing work. And then I realised, well, what they were doing was just finding bugs. Well, I can find bugs. Okay, I've found my common ground. My main issue is more that I've found a million bugs. If you go... well, penetration testers are amazing in the completed product. If you can imagine how many just knucklehead can't believe I didn't think of it bugs you fix during a development life cycle. You really need to understand there is a tremendous category of bugs that get fixed before it becomes a product. So bugs are home turf for me, in fact. So this is top 25 software errors. A little dry, a little academic. Okay, so, bad SQL injection, really? Still? Okay, fine, it's still a thing. Okay, let's go through a few of these other ones. Uncontrolled format strings, buffer overflows, apparently still a thing. Dangerous download of code without integrity checks. These things are not rocket science. None of these things are breathtakingly complicated, but they are complicated enough for teams of time-poor humans who aren't focused on security to let slip through. And a lot of them are fairly straightforward. They're straightforward to talk about. They're straightforward to find. But they're not straightforward to find all of every time and give feedback to developers who might not be aware of them and their managers and their organisations. So the challenge, I think, is how do we actually genuinely uplift something like an organisation rather than just an individual? How do we make sure that your next round of pen testing reports don't, well, we fixed the five horrible, terrifying ones they found and we gave it to the team and then they put it on a shelf because they got moved on to the next feature and then eventually the manager moved on and now the new manager has a document somewhere on their shelf. Okay, how do we fix that problem? And the answer is you have to bake it in. You have to bake this stuff in. So I don't want a pen testing report. I want automated tools from my pen testers. I want rules coming back from my penetration testing that I can bake straight into my software engineering processes so that I know that we do that thing every single time. Now, that's not going to be possible for everything, obviously, particularly system configurations and so forth. But there's more that we can get from the relationship between software engineering and penetration testing than we're getting now. And there's more that we can get out of our build systems than we're getting now. Okay. So old hat. So this would be a fairly well-agreed, uncontroversial developer's view of what you can actually detect with static analysis tools. So this is pitching to the people in the audience who may not be at the point of having sort of picked all this stuff up yet. I assure you it's worth doing. It'll take a little while to get your devs on board. Many of you will genuinely find this a bit old hat. But let's talk about some things that can be picked up. Hard-coded passwords, redundant code. So let's imagine you've got a CV, you're managing a product. Let's go, just put my product manager hat on. There's a CVE in it. You fix that 10 lines of code or 100 lines of code. How do you know that those same lines of code aren't somewhere else in your 500,000 lines of code? Okay? How do you know that someone hasn't copy-pasted that? Forget library dependencies and beautiful, well-managed things. How do you know that someone didn't just copy-paste that into something and put a gist up on the web somewhere and go, hey, download this, it does it. One of your other devs put it in some other product. How do you go find that stuff? You actually need to get back to the source code level. You can't just deal with it at a CVE level. Linters and syntax checkers. People think that is not amazingly relevant to security, but what it does is it simplifies the journey. So like basic things like regular expression searching works well if the code has a consistent naming strategy. It works poorly otherwise. So if you need to global find where a particular CVE set of source code is, that's going to be an easier job if everything's nice and consistent and easy to read and easy to look at. So as you try to connect back the fix to something that's genuinely going to provide you hardening beyond the next CVE, this stuff starts to become more relevant. As you give it to a new dev, it's easy to get someone behind an automated tool if the automated tool has a simpler job to deal with because everything's nice and well organized. So that can be picked up. Unused code, dead code, branches you can't reach, etc., etc. That's all worth turning off. Whenever I read the I don't know, top essential 4, top 8, 94 things, whatever it is. One of them is, turn off non-required functionality. And every time I hear that, I hear, I've got to find all the dead code. I've got to find all those code branches which weren't designed to be hit, so I never tested them. But if someone can call that function, it's actually still there. How do I find all that stuff? So, well, you can find it. It's actually not that hard. You get decent testing, you run it through the rig, you'll get a nice report. Semi-automated security testing. And then there's can pick up, enumeration of so between semi-automated and manual, we're moving now into the world of today's penetration testing, as I understand it. I think I've been really clear. I'm a dev, and I don't understand penetration testing. I'm not one of. They've all sat over here, so that one of you guys. I don't know how they must all be in the same club or something. I'm not sure, but I'm not trying to speak from that perspective. I'm trying to speak from the developer perspective. As I understand it, that moves very much into the world of traditional security testing or penetration testing. Okay, great. So we've got all of that. If you've got all of that, you're in a really good state to be ready to take advantage of the next round of technical innovation, which I think will be coming soon. Let's just talk a little bit about existing tools, commercial and open source, like some of their shortcomings. So this is moving into what's next. What is the next generation, the next innovation? So problems. Okay, center of the universe tools. So I understand you've got a nice product. Probably it's got a legacy of its own, and it got built in a time when people didn't have Travis CI and Jenkins and GitLab CI and XUnit reporting and all of these beautiful things. So you had to build some kind of information center of your own. And this is true of some open source tools as well. It's not a universal criticism. The output formats are all different and nothing, they're not necessarily a nice, coherent 1 to 5 severity scale on these things, which is consistent by tools. But anything that thinks it's the center of the universe is going to be expensive to adopt. People aren't going to want to pick it up because of their existing investments in other technologies, or they're going to see it as this big decision. They're going to need to do some big evaluation of all these alternatives, and someone's going to have to really argue for the right one, and then the perfect becomes the enemy of the good. You don't pick it up because the one that fixes all the problems that some people want costs too much, and the one that's easy to integrate doesn't do all the things, so you're going to be in a debate about that. And the 20 little funny open source checkers that all find 2 problems each but do that one thing really well, they're just nowhere in this solution. So tools that think they're the center of the universe are a problem. Context-free keyword matching and regular expressions. So a lot of the rule engines in both the commercial and the open source tools they're not amazing, okay? They're like, I haven't fully explored all of the commercial tools, so I'm not going to sort of speak ill of any vendors, and certainly also not of the open source tools, which also have limited capabilities. But like the tools will pick up useful things, but they're noisy, they're often wrong, and they will miss stuff, and they don't need to. And it's because they're based on basic rules. So we need more semantic understanding. We need all this stuff to be powered by machine learning. Okay, and what can we? The key to that is like, what can we actually achieve with the machine learning? Like, do we just feed our code base into the Google Brain and a nice pen testing report will come out? No, probably not. But we can do things like categorize code. Sentiment analysis is a machine learning technology, which is basically, you do that on some input text. Did we like it? Did we not? Did it get a positive rating on TripAdvisor? Did it not? Customers also bought things like this. Basic categorization. Security issue? Not a security issue. Front-end code, back-end code, administrative script, application logic. These kinds of categorization can be applied to the code that we write, and I'll show you where some of those shortcomings are in some of the open source tools in a minute. Okay, so that's entirely possible. Commercial versus open source. So I don't want to get into, religion and politics on this particular topic. It's more that if you want people to be able to easily, paying for extended capabilities, that makes a whole bucket of sense. We absolutely want the ability as organisations and as customers to pay for extended capabilities. But the basics, can we integrate this thing? Can we turn it on? Is it going to work with our stuff? All of that, none of that is core business to issue detection. All of that is just overhead. It's just the cost of adoption. So if we can just go a decent freemium model with some basic common standards between the open source and the commercial tools, we will all make more money and everything will be cheaper, because what we're doing is reducing the cost of the overhead, not the value of the tool. So it's possible to have, if not the best, better of both worlds. And language frameworks need to be able to better this one's totally out of left field. It doesn't relate to anything else I've said, but it's just this thing I wanted to include, which is that our language frameworks should be able to be marked up and said, well, this thing is some user input. You know, let's start to see languages saying security is a first-class concern. Let's allow our language features and our frameworks to have better tagging around what kind of things are coming up, so that our scanning tools go, oh, this is user input. I'm going to turn the paranoia up to 10 when I'm wondering whether this string could be manipulated. Oh no, this is an admin script. I'm not going to worry about the fact that it could be misused because an administrator is doing this. Okay. All right. Okay. New possibilities. I promised I'd do something new. So let's talk about where we're going. So tools that are in IDEs. Okay, lots of people have really nice IDEs. Lots of people don't. The extended supply chain, this will not be everywhere. So absolutely we can continue to uplift as an industry. Static analysis tools typically aren't really clear about what's going on from a security perspective with the issues they find. There's often a distinction between security static analysis and regular static analysis. So with any luck, they'll just sort of slowly eat security tools and it'll just become the tools all over again. Automated testing, often there's separate frameworks and plugins for doing things like fuzzing and the kinds of activities a pen tester might do. So you need someone to go, oh, I'm going to go evaluate all of these security libraries and turn them on. But a lot of them are real no-brainers. Okay, there's a lot of things which just should be on. And dynamic analysis is still difficult. We can do it. It's the commercial tools, as far as I can tell, seem to be doing dynamic analysis. And by that I really mean things like tracing call execution flow through an application so you can understand better where your user input is reaching and which databases it's hitting, because you might not realise, particularly as I said, if it's, you know, imagine it's your first job and you don't actually know this thing backwards. You might not realise that, you know, a piece of user input A can in some circumstances actually reach this database over there. So there's a lot there. Okay. So can we really do better? So I'm in the home straight. I've got 8 minutes to go. I'm going to leave some time for questions, so we're going to just race through a few basic examples of deliberately horrible code that I would never write, just to show you what the tools can do. Okay, so just to be super clear on that. Okay. Has Vim come up over there? Yes, Vim has come up over there. Okay, so what I've got here is a hard-coded password and some dodgy SQL. Okay, so if we look at our dodgy SQL, so we've got insert into the administrative tables, user and password field, anything the user supplies. Okay, so we'd probably like our tools to be able to detect these kind of things. Select star from secrets where any query the user supplies, and then, you know, it's still horrible SQL, but it's like much neater. You know, so this is the kind of code probably that I'd be closer to, like, it wouldn't work like this, but the structure of it, building up the string, etc., that is probably more like what you'd actually see in some code if someone was going to build up a query string. Okay, so Bandit is an open source tool for detecting Python issues. So let's run Bandit over our dodgy SQL. So it's found a couple of issues. So let's see what it's found. It's found, okay, it agrees that inserting into the administrative table anything the user has supplied is a bad idea. But what it said is, oh, possible SQL injection. Really? Possible? Like, that's more than possible. And ditto with this select, but it's missed the extended string construction. Sure, I have no doubt that this would be a day's work for someone to go in there and actually improve the rules that are doing the recognition without going all the way through to machine learning. But if we can start to get some more general abilities to detect and learn negative patterns in code, we're going to be doing a lot better. And like I said, there's no question about machine learning, whether it works or not. It obviously works. The question is whether or not we can frame our code static analysis problems as machine learning problems. It's a data issue, not anything else. Okay, so I've got one more example, which is some dodgy passwords. So if we pull up passwords in code using the well-known MD5 library, because I wrote this 20 years ago, let's go through a few examples. Okay, so we've got a super secure password management API that we're calling, and what I'm just doing is comparing what it is that Bandit's going to ping off versus not ping off when we look at these tools. Okay, so it finds password equals the hard-coded string password. Yay. This will actually happen, and you should actually find it and turn it off, because people, when they're writing the first version of their code just on their laptop, will write test code like this, and if you're not careful and if you don't have the tools, it just might make its way into prod if no one... you don't have to beat your senior dev, you've got to beat your intern. You've got to beat your first year student. You've got to shift the mindset around, can these tools do better than a smart person? Because the smart person just doesn't scale. I can't photocopy them and have them running 25 times a day on 100 projects. I just can't do it. Okay, so admin password, so this one is also fine. So it's also a hard-coded password, but I use the extremely tricky obfuscation of not using the variable name of password, and it just flies on past. Okay, so these things are not complex to extend. And as penetration testers and as people investigating the code, you could be providing better rules back to these detection capabilities. You could do a pen testing report, say I found this in your code, and also here's some code to add into your Bandit framework so that you're just never going to catch it again. We can be getting more value out of this. And then your pen testing reports aren't just going to sit on a shelf. They're going to sit there adding value every day. That's where I think we need to head. This thing here, uncomment, use password 343 if you want admin on the real server. That's the kind of thing a junior sysadmin might just stick in the script that they've got for themselves. It's the kind of thing that if you're just not particularly focused on whether someone you didn't expect was going to access and read this script, you might just store away. There's the prod version, there's the dev version, just chuck it in there. It seems incredibly obvious, and really as soon as you've been to 2 security conferences or read 2 books and actually had your manager tell you it's important and get caught out by a senior dev, well, sure, you're probably not going to do it again, probably, but it's really worth having these tools in place. So that's the end of my live demo. I would have loved to get into actually doing some of the machine learning techniques, but what I really want to show you is that these rules are basic, useful, and can be extended, and there's a lot more we can do. So in conclusion, there really is a world of extra possibility still in static analysis. If you're a pen tester, you can come and use all our static analysis tools, and penetration testing is not the only or even the most important means of shifting that equilibrium on the economics. It's important, but it's not the only thing. All right, thanks. I may have used all the question time already, I'm not sure.
No, we have about 7 minutes.
7 minutes.
I didn't see any questions flowing through the app, so I don't know if it was working or not. Maybe it was a poor coding bug or something like that. But if you do have any questions and you just didn't use the app, yeah, definitely, I'll come around.
Thanks for that. If you're starting out on this journey to kind of implement kind of what you're talking about in terms of secure coding, and your organisation does have CI and a number of other dev tools in place, and there's a fairly decent development team, a mixture of skills, etc. What is your top 3 things, or top 2, or top 1 thing in the next step in the journey that you should try and do? Is it tooling? Is it training? Is it management support? I mean, what is the number 1 thing to sort of move you along that journey?
Yeah, if you've got the buy-in from one team that can start this on their own, that's probably you can certainly uplift it team at a time. So if you've got the buy-in from one team, you can get some runs on the board from one team. If you have a mechanism where that's going to be recognised, then that'll be enough. I.e., if your team just starts producing better outcomes and the pen testing reports get better and everyone goes, what a great outcome, you're solid. If your management is in, or your organisation's in the situation where they can't tell the difference between a well-functioning team and a less well-functioning team in terms of those outcomes, then you've got a whole different set of questions and you're going to need to educate your management. In terms of educating the developers, I think the first thing is the basic tools. Just go static, just basic syntax style guide checking. Just do that and they'll start to get used to it. Get it into their IDEs. You know, so for anyone who hasn't seen it, it's like the Microsoft Word grammar checker. It just comes up and tells you stuff about the quality of your code as you're going. And then just have conversations with people about the quality of their code and what these indicators mean, and just build the grassroots support. If you want to do it as an entire organisation, work out whether you're going to run it as a project or whether you're going to do it through BAU. And get the support of your ops team as well. So that they will generally get on board with you, because they're generally very supportive of anyone who's going to take a security conscious approach to the work. Show them the tools, show them the reports, etc., and get them excited about what you're doing. That's usually pretty easy to achieve as a rule. Devs and ops don't necessarily, you know, have those conversations much.
You mentioned scientists. I'm wondering how you at the BOM capture them under your code quality system. They're often a force of their own. They're often not part of the dev team formally. They often haven't been trained in any of this stuff. Have you had any luck applying these systems to your rogues?
Yeah, well, mixed. I mean, you know, we're talking about people here. It's always going to be mixed. They're generally really smart. So if you can get them excited about the challenge of what you're trying to solve, then I think you've got a lot of the way. Scientists tend to be very much based on their own skills and capabilities, perhaps a bit like a penetration tester is, focused on, you know, there's a reputation there as a scientist that they're managing. And if you, which means that going, oh, well, here's the new policy, isn't really a great way to reach them. It's going to be much better, hey, I ran this tool, I found a bunch of things, can we go through them? And then do the same thing a fortnight later. Don't make them run it, you run it and go, hey, I'd like to have a chat. And turn the tools down to their lowest setting and just have a chat to them about 20 lines of code that you found. And don't tell them why you're doing it. I don't mean to try to foist it on them, but just treat it as a conversation about what they've built and the quality of what they've built and how you can help them. And that grassroots approach will be fairly successful. They're generally going to want their own autonomy in the scenario, but they will. A lot of them will see the benefits. Some people really get on the journey around things like validation, and sometimes you can, if they're genuinely very quality focused, you can use the continuous integration to do automated testing of their scientific accuracy as well, and then you can get them kind of on board with the whole methodology of the feedback loop. But it's certainly not just easy. Yeah.
Right, we've got time for maybe one more question if anyone has it. If not, sweet, I got some, so that's good. Do you find that the current tooling, being it open source or commercial, actually let's stick with open source because it's mostly free. Do you find that teams nowadays, like a new team, has enough out there in terms of tooling to just get started with these things?
Look, largely yes, I have to say, unless, like, for almost all languages, there's at least 20% coverage from these tools that's useful. So you can turn them all on. The main issue will be noise. If you've got an existing code base, then turning them on for the first time is a challenge. If you're writing from scratch, it's super easy. A lot of the issues will be their output formats are not coherent and consistent across different things. So if we can, there is a tool out there called Koala, spelt with a C, which is just awesome. But it produces a sort of effectively a common JSON format across being able to integrate it. So you can just treat it as like another part of the unit testing if you have a dev team that knows about unit testing. If you don't have a dev team about unit testing, you need to find a human who knows about unit testing and get them to embed for like 2 months to get it all off the ground, and then it'll be all right.
Alrighty. Were there any other questions at all? Great. Well, I'd like to thank you very much for the presentation. Can we have a warm round of applause, please?